There are many uses for machine learning in various industries. But what exactly is machine learning, and what are the popular algorithms used to enable systems with machine learning? These are some of the questions that I will answer in this video series. In 1959, Arthur Samuel coined this term, which he defined as a field of study that provides learning capabilities to computers without being explicitly programmed. Today, we typically envision it as computer systems that can think and learn on their own. Machine learning is effective in tasks performed by human beings and tasks beyond human capabilities. Examples of real-world applications of machine learning with high-performance output are email spam filtering, fraud detection, online stock trading, face and shape recognition, product recommendation, and movies and TV show suggestions. The generic model of machine learning consists of six components. First is the collection of and preparation of data. The data needs to be cleaned and pre-processed to a structured format that can be given as input to the machine learning algorithm. Second, feature selection. It means only the needed data that are relevant to the learning process should be obtained. Third is the choice of algorithm. There are many algorithms to choose from. Selecting the best algorithm for a problem at hand is imperative in getting the best possible results. Fourth, selection of models and parameters. Most machine learning algorithms require some initial manual intervention for setting the most appropriate values of various parameters. Fifth is the training of the model using the training data. Sixth, performance evaluation. This is testing the model against unseen data to evaluate how much has been learned using various performance parameters like accuracy, precision, and recall. Machine learning has different learning styles and are broadly classified into two types. First, supervised learning. It is also called learning via examples. In this style of learning, a set of examples or training modules are provided. The algorithm learns to respond more accurately by comparing its output with those that are given as input. The model is trained with known input and output data so that it can predict future outputs accordingly. In short, it is a method of inputting labeled data into a model to predict future outcomes. Categories of supervised learning are regression and classification. Regression is used if there is a relationship between the input variable and output variable. It is used for the prediction of continuous variables such as in weather forecasting. On the other hand, classification is used when the output variable is categorical, which means there are two classes such as yes-no, male-female, and true-false. An example of its application is in spam filtering. The second broad type is unsupervised learning. In this approach, the training data is not labeled, which means we have the input data but no corresponding output data. It recognizes unknown patterns from the data in order to derive rules from them. Categories of unsupervised learning are clustering and association. Clustering is used when grouping the objects into clusters such that objects with the most similarities remain into a group and objects with less or no similarities go to another group. An example of clustering is grouping image datasets such as types of fruits. On the other hand, association is finding the relationship between variables in the large database. It determines the set of items that occur together in the dataset. This is typically applied to market basket analysis. Let's say people who buy bread also tend to purchase butter. To recap, the supervised learning approach develops predictive models based on both input and output data. The algorithms under this approach can be categorized as regression and classification. The unsupervised learning approach groups and interprets data based only on input data. The methods under this approach are categorized as clustering and association. There are a number of algorithms for machine learning. When we say algorithm, it is some definitive computing method that seizes several values called input and generates some results called output. Linear regression, decision tree, support vector, k-nearest neighbor, naive Bayes, and neural network are some of the popularly used kinds of machine learning algorithms.